Hi everyone, my name is Jayashree. I'm BTech first year student from ECB section. Today, my engineering physics PPT presentation is about semiconductor quantum dots. Now, let's go into the topic. Here you can see the outline which I prepared in this PPT. The first one is introduction, and then what is a semiconductor quantum dots, why quantum dots are used, properties of quantum dots, synthesis, application, challenges and potentials, and then conclusion. Now, let's see the first introduction. Here the introduction. Quantum dots are semiconductor nanocrystals. Here, what is meant by nanocrystals? Nanocrystal is a material particle having an at least one dimension smaller than the 100 nanometers. So this is meant by nanocrystals. Then they are made of many of the small materials as ordinary semiconductor, mainly combination of transformation metals and or metalloids. Here, unlike ordinary bulk semiconductors, unlike ordinary means different bulk semiconductors which are generally macroscopic object. Macroscopic means involving a large unit of elements. Quantum dots are extremely small, on the order of few nanometers. They are very near to the zero dimensional. Here you can see the picture of the structure of quantum dots. Here the blue color is QD core and the red color is QD shell, and the outer layer is a protective shell. So you can see over there in the introduction. And then the bulk semiconductors. What is mean by bulk semiconductors? Electron in the conduction band are in free to move in all the dimensions of the space. Here, the electrons which are present in the conduction bands are free to move in the space in the three dimensions. Here, the bulk semiconductors are characterized by the composition dependent band gap energy, which is a minimum energy required to execute an electron from the ground state valency energy band into the vacant conduction energy band. Here you can see the picture of the bulk band structure. So you can see over there. And next, thin film semiconductor. What do you mean by thin film first? A thin film is a layer of material dragging from the fraction of a nanometer to the several micrometer in the thickness. In general, semiconductor thin films are produced in one or more thin layers. Common application of such structure includes many electronic materials such as transistors, sensors, and photovoltaic devices. Here, the first one is electron in the conduction band are free to move in two dimensions, confined in one dimension by the potential wall. Potential wall created due to the large band gap of semiconductor on the either sides of thin film. Thinner flips leads to the higher energy level. These thinner flips leads to the higher energy level. Over the bottom of the slide, you can see the picture over there, thin film semiconductor. And this is about the thin film semiconductor. And next, what is the quantum wire? Quantum wire are extremely narrow structure where the electron transport is possible only in the very few transverse mode. Here, the thin semiconductor wires are surrounded by a material moved to the larger band gap. Surrounded material confines electrons and the holes of dimensions. Carriers can only move into the one dimension larger band gap. Quantum wires acts as a potential wall. Here, the quantum wires acts as a potential wall. Okay, and this is about the quantum wires. And next, quantum dot. What do you mean by quantum dot? Quantum dots are the semiconductor particles a few nanometer in size, having the optical and electronic properties that differed from larger material particle due to the quantum mechanics. So this is mean by quantum dots. Here, electrons are whole or confined in 3 dimensions or phased by surrounding materials in a larger band gap. Discrete energy levels. A quantum dots has a higher band gap like bulk semiconductors. Electron tends to the transition near to the edges of the band gap in the quantum dots. Very small semiconductor particles within the size compressible to the vast radius of expectations. And then here the typical dimensions are 1 to 10 nanometers, and then can be large as several. And they are shares as different shapes, cubes, spheres, pyramids, and also etc. Here, discrete energy levels. First of all, what is meant by discrete energy levels? Discrete energy level means that different energies by different electron path, and quantum mechanics systems or the particles in the bound is confined can only take a certain discrete value of energy called as energy levels. Here the energy levels depends on the size and also the shape of the quantum dot, similar to the quantum dots. Higher energy requires to confine the extensions of the similar volume. Energy levels increases in the energy and spread out more. Here the energy levels increases in their energy and they spread more over. Okay, the higher band gaps energy, the higher band gap energies. So you can see the picture over there. In that you can see the conduction band, valency band, semiconductor, quantum dot, hole levels, photon, electron levels. You can see over there in this picture. And then how to make quantum dots? Here, there are 3 main ways to continue the excisions in semiconductor. The first one is lithography, and then colloidal synthesis. Third one is epitaxy. Epitaxy includes 2 stages. The first one is pattern growth and the second one is self-organized growth. Here, what is meant by lithography? Here the quantum wells are covered with the polymer mask and exposed to the electron to ion beam. The surface is covered with a thin layer metal, then cleaned and only attached into the entire surface. The pillars are attached into the entire surface. The multiple layer are applied this way to build up the properties and size wanted. Here we can see the disadvantages of this lithography is small contamination, a low density and defect formation. Here you can see the picture over there. And colloidal synthesis, immersion of semiconductor microcrystals in glass dielectric matrices, taking a silicon glass within 1% semiconducting phase. Heating from several hours at higher temperature, formation of microcrystals are near equal size. Due to heating for several hours, the formation of microcrystals are near to the equal sizes. They became near to the equal sizes. The typically group 2 to 5 materials. Here, size variations also means the size dispersion. Here you can see the colloidal quantum dots picture. Epitaxy. Epitaxy, the first one is pattern growth. The semiconductor compound with a smaller band gap, GAS, means gallium arsenide, are grown on the surface of the compound in the larger band gap surfaces. The growth is restrained restructured by coating it with a masking compound, silicon dioxide, and attaching that mask with the space of required crystal cell and shape. And here you can see the disadvantages like density of quantum dots limited by the mask pattern only. Here at you can see that the picture of pattern growth by stages. Here the epithoxy, the second one, self-organized growth, uses a large difference in the lactic contest of the substrate and the crystallizing material. Then the crystallized layer is thicker than the crystal thickness than in a strongest strain of the layers. The breakdown results in randomly disturbed islets of a regular shape and the size. Here you can see the disadvantages like shape, size, fluctuations, and ordering. This is about the epithoxy of self-organized growth. Now, scandium free quantum dot. Okay, first in many regions of the world, there is no wise soon to be legislation of restricted and the some cases being heavy metals in many household appliances such as it and telecommunication equipments, lighting equipments, electrical and electronical tools, toys, sports equipment, and etc. From QDs to the commercially valuable in many applications that must not contain cadmium or a restricted elements like mercury, lead, and chromium. They are restricted as like mercury, lead, and chromium. So such have been able to create non-toxic quantum dots by using the silicon. So this is about the scandium free quantum dots. Now you can see the quantum dot lighting emitting diode picture here over there. In the graph, the black line indicates the conventional device and the red color line indicates the device which blocking type. In the blue color, you can see that a devices with trapping type. Here on the y-axis, they take that external quantum efficiency. On the x-axis, the luminances. Here, quantum dots, lighting emitting diodes, means quantum dots LED. The quantum dots LED based light emitting diodes are a new form of lighting emitting technology based on the nanoparticles, and their structure are similar to OLED technology. Although in this technology, the layer of quantum dots is placed between electron and holes transporting layer like sandwich structure. Here, the spectrum of photon emission is narrow, characterized by its full width at half the maximum value. The poor and saturated emission colors within the narrow sandwich, means they are like narrow sandwich. Emission wavelength is easily turned by the changing the size of the quantum dots. So this is about the quantum dots LED. Here the advantages: lower power consumption. It consumes lower power, and the ranger and accuracy color. The brightness is 50 to 100 times brighter than CRT and LCD. The display is 40,000 CD per meter square. QLED screens are said to be the twice as power efficient as QLED screens and offer 30 to 40% improved brightness. Here the disadvantages are less saturated blue. This is less saturated blue and this is very expensive. So these are the advantages and disadvantages of LED. Then Then quantum dots solar cell. What do you mean by quantum dot solar cell? Quantum dot solar cell is a solar cell design that uses quantum dots as the absorbing quantum photovoltaic material. This properties makes the quantum dots attractive from multi-junction solar cells. When a varieties of materials are used to improve the efficiency of harvesting multiple portions of the solar spectrum. Here, the quantum dots has the bandages that are tunable across a wide range of energy level by charging the quantum dot size. Here, here you can see the picture over there. At the top of it is minic contact and then AR coating. On the middle, you can see P-type cap. On the middle, the yellow color balls they denotes quantum dots, and then down it is N-type cap, and at last Omnic contacts. This is about the quantum dot solar cell. Here you can see the picture of it. On the y-axis, they took as external quantum efficiency, and the y-axis you can see the wavelength. Here, efficiency. Quantum dot can generate multiple extensions, electron hole pair as collision with one photon. Here, quantum dots has a potential of dramatically increases the efficiency of converting the sunlight into the energy, perhaps even doubling it is some devices because of their ability to generate more than one bounded electron holes pair or excision per increasing atom. Here, the wave like that you can see that is in the picture. You can see that the wave like red color, that is incident photon, and excision electron hole pair and the band gap between them, and 0 point vibration vertebral energy of the existed, so that you can see the picture clearly over there. I mentioned. Next, here the picture that spin cast quantum dot solar cell. You can see the picture of that, and here roll to rolls solar cell fabrication. You can see the picture over there clearly, and the result of this is conversation efficiency is up to a record breaking is 7% efficiency. The record breaking, it has 7% efficiency. The efficiency of solar cells could be increased to more 60% from the current limit of just 30%. So this is the result of solar cell. Then the other applications are photo detector device, quantum dot laser, colloidal quantum dot, uses in biology, uses in biology, use of QDs as a passive labels in sensor applications, gene technology, and pathogen and toxic detection. So these are the another applications. Here the challenges and potentials. The potential. The composition and very small size of quantum is 5 to 8, given them unique and a very stable fluorescent optical properties that are readily tunable by challenging their physical composition or size. Their broad absorption spectrum but very narrow emission spectrum always multiplexing of many quantum dots of a different color in the colors in the same sample. They are in same sample. Now, the quantum dots can be made from many different elements and comes in many shapes and sizes. The quantum dots are made from many different elements. They're made from so many different elements, many shapes and sizes also. The challenges while preparing these quantum dots, we face that hard to control the size of the dot. It is very hard to control the size of the dots. And it is a cytotoxic effect, sorry. Environmental toxicity, first one is phytotoxicity and second one is marine toxicity. Then thank you. Here you can see the conclusion. Quantum dots are the new and innovation perspective on the traditional semiconductor. The quantum dots cannot be synthesized to be effectively and size, and therefore they produce effectively any essentially and wavelength of light. Application of quantum dots that they are usual